Good morning, my dear students. In this video presentation, again, we'll discuss some more problems meant for class 12 of CBSE, which are very often tested in the board. All of the sums will be very useful for your board examination. Concentrate fully and understand each and every step being discussed here in every other video. The first question meant for today is from maximum minimum. The question goes like this. The sum of perimeters of a circle and a square is k, where k is a constant. Prove that sum of their areas is least or minimum, both will imply you the same when side of the square is double or twice the radius of the circle. Let me just repeat. Sum of the perimeters of a circle and a square is k, where k is a constant. Prove that the sum of their areas is least when side of the square is double the radius of the circle or twice the radius of the circle. Let me assume first, let the radius of the circle be r units and side of the square be a units. Now what is given? 2 pi r plus 4a is equal to k. K is a constant. This is given to you in the question itself. The very idea of something is constant means if I'm going to think about derivative of this with respect to any variable for that matter, it is going to be 0, which you are supposed to remember while you do further steps in this particular problem. Circumference of the circle 2 pi r plus perimeter of the square 4a, addition of which is supposed to be k. Listen carefully. Now combined area or sum of their areas, either way you can write. Combined area, I call it as capital A. Some letter I am supposed to use. Here it is nothing but pi r square plus a square. Area of a circle is pi r square and area of the square is side square a square. But there are two variables involved, r and a. Either I should bring r in terms of a or a in terms of r. Either way you can do. Therefore this is pi into, I mean to say, k minus 4a by 2 pi the whole square plus a square. This is from 1. See here, I can replace r by k minus 4a by 2 pi. This is supposed to be 1 by 4 pi. Listen carefully. Pi by 4 pi square becomes 1 by 4 pi into k minus 4a the whole square plus a square. I am able to get the area capital A in a single variable small a. Now I need to find the value of small a, for which first derivative is 0 and second derivative is positive. For area to be minimum, second derivative should be positive. If the area has to be maximum, second derivative has to be less than 0. Okay, remember carefully. Now d capital A by d small a is 1 by 4 pi into 2 into k minus 4a into minus 4 by chain rule of differentiation. Okay, here anyway 4 gets cancelled, which can be written as, I will multiply this minus 2 by pi inside. Therefore this will be minus 2k by pi plus 8a by pi plus 2a. Let me check. Minus 2 by pi into k, minus 2k by pi, minus 2 by pi into minus 4a plus 8a by pi. Now I'll be able to think about the second derivative now. This is supposed to be is equal to the whole thing, everything is 0 here. Here it is reduced to 8 by pi. This is reduced to 2. There is no a involved, but both the quantities are positive. It's always positive for any value of small a. Now taking dA by dA, small a is equal to 0, I end up with minus 2k by pi plus 8a by pi plus 2a is equal to 0, which implies 2k by pi is equal to 8a plus 2a pi by pi. After taking LCM, this pi gets cancelled. I'll end up with k is equal to 4a plus a pi. I am cancelling out 2 throughout. Therefore, when k is equal to 4a plus a pi. First derivative d capital A by d small a is 0 and d square capital A by d small a square is greater than 0. Implies a is least or minimum, both are same. When k is equal to 4a plus a pi. Let me try to simplify what happens here. 4a plus a pi, which implies 2 pi r plus 4a is equal to 4a plus a pi. This 4a gets cancelled. 2 pi r is equal to a pi. Pi gets cancelled, which implies a is equal to 2r. Side of the square is twice the radius. That is what I am supposed to prove anyway. You can take down and write the final answer. That is, for the combined area, sum of the areas to be minimum, side of the square to be twice the radius. Let me repeat the whole process. Let the radius of the circle be r units and side of the square be a units. Sum of the perimeters 2 pi r plus 4a is equal to k, where k is a constant that is given in the question. I'll name it as 1. I'm going to use it further. Combined area, sum of the areas, either way you can write. I use another letter, capital A, pi r square plus a square. Being area, I use capital A. Pi into k minus 4a by 2 pi whole square plus a square. This is from 1. I am replacing r by small a from 1, which will be equal to pi by 4 pi square, because 1 by 4 pi into k minus 4a whole square plus a square. I am able to get area capital A in a single variable small a. I am supposed to think the value of small a, for which d capital A by d small a is 0, d square capital A by d small a square is greater than 0. First derivative gives you 1 by 4 pi into 2 into k minus 4a into minus 4 plus 2a. First one is because of chain rule of differentiation. And of course, taking minus 2 by pi inside, it becomes minus 2k by pi plus 8a by pi plus 2a. Getting the second derivative, everything is a constant here, derivative is 0. 2 is a constant, k is a constant, pi is a constant. Of course, minus 2 is a constant. Okay, along with minus sign, I mean. For here, derivative becomes 8 by pi plus 2. There is no a involved here. All the quantities are positive. 8 is positive, pi is positive, 8 by pi is positive, 2 is positive. Therefore, it is positive for any real value of a. Equating d capital A with dA is equal to 0. I end up with minus 2k by pi plus 8a by pi plus 2a is equal to 0. 2k by pi is equal to 8a plus 2a pi by pi. Pi gets cancelled. K is equal to 4a plus a pi, dividing throughout by 2. Therefore, take down and write the condition specifically. When k is equal to 4a plus a pi, first derivative is 0, second derivative is positive for capital A with respect to small a. Now, for this, the condition for local minimum. Now, for a is least when k is equal to this much. K is replaced by 2 pi r plus 4a here. 4a gets cancelled. 2 pi r is a pi, implies a is equal to 2r. Therefore, from the question, take away, prove that and write everything. That is, sum of the areas is least when the side of the square is twice the radius or double the radius. Okay, it's better to take down and write the final answer. I haven't written the final steps, etc. Remember carefully. Any such situation may be given accordingly. You'll be having two different variables. Bring one variable in terms of the other, and then think of the first derivative, second derivative. For local minimum, first derivative should be 0, second derivative should be positive. For local maximum, first derivative should be 0, second derivative should be negative. You may be given to think about curved surface area to be minimum, total surface area to be maximum, volume to be maximum, volume to be minimum. Accordingly, you proceed with the problem. Therefore, it's only an example. Rest you anyway think over. Now, let me think about the next problem. Evaluate integral root of x plus 4 by x plus 1 dx. It's not a difficult problem. Just listen here how we go about it. X plus 4 by x plus 1 dx. What I will do is, I'll multiply and divide by root of x plus 4 in the second step. Root of x plus 4 dx divided by root of x plus 1 into x plus 4. This will automatically become x plus 4 dx by root of x square plus 5x plus 4. 4x plus x becomes 5x. After bringing it to this format, it's the form integral px plus q dx by ax, root of ax square plus bx plus c. The application is numerator equal to capital A into d by dx of quantity within the root plus capital B. After finding capital A, capital B, we should proceed. But there is an easy way to do here. I'll multiply and divide by 2 by root of x square plus 5x plus 4. I am giving an easy method. Here x plus 4 can be written as half of 2x plus 8. Can be written as 2x plus 5 plus 3 is easier to write anyway. X square plus 5x plus 4. Here if you seriously apply the rule x plus 4 equal a into d by dx of x square plus 5x plus 4 plus b, my a will be automatically how much? A will be half. My b will be 3 by 2. Remember carefully. Therefore, this is the form half integral dt by root t plus 3 by 2 integral dx by root of x square plus 5x plus 4, where my t is x square plus 5x plus 4, which is half integral t power minus of dt plus 3 by 2 integral dx by root of x square plus 2 into 5 by 2x, add and subtract 25 by 4. I am trying to make this as a perfect square. 4 minus 25 by 4, which is half into t power half by half plus 3 by 2 integral du by root of u square minus 3 by 2 the whole square. You can just check. 4 into 4 is 16. 16 minus 25 is minus 9, where my u is x plus 5 by 2. Therefore, here 2 gets cancelled. This is root of x square plus 5x plus 4 plus 3 by 2 log mod u plus root of u square minus 3 by 2 the whole square plus c. Now this is root of x square plus 5x plus 4 plus 3 by 2 log mod x plus 5 by 2 plus, this is the original one, x square plus 5x plus 4 plus c will be the final answer. Let me just repeat the whole process again. The question given to you is root of x plus 4 by x plus 1 dx. The dx is not written properly, just it's not. Okay, I will just write it again. Multiply and divide by root of x plus 4 in the second step, so that the root will go off in the numerator. It will become x plus 4 dx by root of x square plus 5x plus 4. Now, practically speaking, I should write x plus 4 is equal to a into d by dx of x square plus 5x plus 4 plus b. Instead, I'll multiply and divide by 2. It becomes 2x plus 8 into half. See here, 2 by 2 is x, 8 by 2 is 4. This 8 can be written as 5 plus 3. Now, I'll make it into two integrals. Half of this is nothing but derivative of the quantity within the root. dt by root t, where t is the quantity within the root in the denominator, plus 3 by 2 this. Here I'll make it as a perfect square. 2 into 5 by 2x plus add 25 by 4, subtract 25 by 4. 16 minus 25 is minus 9 by 4. It's of the form du by root of u square minus 3 by 2 whole square, where u is x plus 5 by 2. Here root t is root of x square plus 5x plus 4. Plus 3 by 2 log mod u plus this. U is replaced by x plus 5 by 2. This is originally the reduction of this. Write it as it is. Now for root of x square plus 5x plus 4 plus 3 by 2 log mod x plus 5 by 2 plus root of x square plus 5x plus 4 plus c is the final answer. Only thing is, multiplied by root x plus 4. That's a step you should remember. And here, if you are not very thorough about going this method, it's very easy. Still, if you are not very thorough with this, use the method x plus 4 is equal to capital A into d by dx of x square plus 5x plus 4 and do. I'll show the other method also here for your convenience. X plus 4 is equal to A into d by dx of x square plus 5x plus 4 plus b. Therefore, x plus 4 becomes A into 2x plus 5 plus b. Therefore, x plus 4 becomes 2ax plus 5a plus b. See here, 2a is 1, a is half. I am getting a is half. Now, 5 by 2 plus b is you mean to say 4. Now for B is 4 minus 5 by 2. I get 3 by 2. My B is 3 by 2. Now for if you are not sure about this method, apply this method. I am getting my A as half, B as 3 by 2. That's what even I have got here in the simplified manner which I have already written. Anyway, I'll check for the I'll check for the calculations as usual. Otherwise, I'll upload as it is. Thank you, students, for patient watching.